We are the computer engineering majors of Challenge 2012. Roll call.
Darian.
Sanitra.
Gabriel.
Kyle.
Oscar Oken.
What is computer engineering? As computer engineers, we usually study the use of computer as a modern day tool. Computer engineering is more about the hardware, less about the software. Electronics and circuits versus programming in theory is what we're kind of really confused with. Computer engineering is usually about the electronics and circuit, and CS or computer science is usually about more programming and whatnot. Classes under electrical engineering also focus on circuits, control systems, electronics, and embedded computer systems, computer architecture, and etc. So basically, electrical engineering is very closely tied with computer engineering. And on that note, we want to go ahead and start off with some of the industries that computer engineering branches off to. We have consumer electronics industry, the semiconductor industry, and then we can also go off into the video game industry, telecommunications, and robotics. And then one of the biggest ones is security, which is the most looked at, the IT security, computer engineers, which can be found in the government and pretty much anything that needs security in the computer. For the first branch, consumer electronics industry, they usually focus on products used daily with concentrations in entertainment, communications, and the office. The industry trends are usually lower prices from advanced in technology. So the more advanced technology, they try to lower prices for it, but sometimes it doesn't go that way. Computer engineer roles are to improve the style, price, and performance of products.
The consumer electronics industry focuses mainly on products that are used day in and day out. This includes entertainment such as cell phones and TVs, tablets such as iPad, iPad 2, communications, which is also, it can be cell phones as well, and office supplies like printers, fax machines, all that. So current industry trends for consumer electronics industry is lower prices because of course technology is expanding. We're getting quicker, faster semiconductors. It advances so well that the price of things will drop because they're so abundant now. So it's readily available for more people in a wider scope of technologies. So the computer engineering's role in consumer electronics industry is to improve the style, price, and performance of products. They will make iPads better, which is why they come out with iPad 2, iPad 3. The same for PlayStations and gaming consoles, as well as sleeker, smaller, faster phones that everyone can use. And it's obviously more affordable because they have it more available. Almost every phone company will have a touchscreen phone. They have the iPads and Android, so yeah, that's definitely an example of how technology has expanded and how the consumer industry has a place for computer engineers.
Telecommunications industry is one of the largest industries in the world based on CS, computer engineering, and electrical engineering. The telecommunication industry is basically transferred by transmitting of information to multiple destinations globally by using visual signals or audio signals. One basic example is the internet, or for instance, if a company is trying to sell their product to, let's say, a company in Japan, they're obviously going to need some way to communicate. And this is what the telecommunication industry is based upon. They are trying to improve our communication system and carry us onto the future. So examples of these would be visual signals, beacons, smoke, signals, signal flags, optical holographs. These are examples that were based upon on the past. And as you see now, we have enhanced those by using audio signals, coded drum beats, whistles, etc. Now, how does computer engineering fit in this space? Well, computer engineering is based upon software and hardware. In this case, we are more emphasizing software because we need the codes and we need the signals that are going to transfer this information across globally or from your home to another person's home. Hardware, all the cables based upon to transmit this information through, that's the hardware portion of computer engineering. Now, the semiconductor industry. Semiconductor industry basically follows the idea of Moore's Law. What is the Moore's Law? It basically states that every 2 or 3 years they improve their hardware in order to facilitate people's everyday lives or companies. So it is widely recognized as a key component for economic growth and technology. Now, The computer engineer's role is to focus on the application in communications and information processing and use nanotechnology to create new technology for energy.
Another growing branch in information technology is security industry. And as I'm sure you can guess, this branch is constantly changing because there's always a new virus out, and this branch needs to adapt to be able to combat that new virus. And the government particularly highly desires computer engineers for security industry. The government also desires computer engineers for building and programming supercomputers. This has led to a global race in creating the most efficient supercomputer. Current nations in the race are the USA, Japan, China. But no matter how efficient your computer is, you'll always need security as long as you're going to have any sort of networking with that computer. If it's going to stand alone, it can still receive a virus if it's placed directly into the computer. So no matter how advanced your computer is, security industry is always going to need to play a really large role in that.
In the robotics industry, computer engineers help build robots to carry out multiple functions that a normal individual human cannot accommodate. It's a growing branch of technology and engineering, and it will probably play an important role in our society in the future. Computer engineers mainly do all the programming aspects to make the robots function as we need them. The hardware portion is typically done by electrical or mechanical engineers, but computer engineers also get involved as well.
So we interviewed James Steinberg, and James Steinberg, he's on the faculty in the College of Electrical and Computer Engineering. James Steinberg transferred into tech after 2 years at Florida Community College. He majored in semiconductors with a minor in power. He maintains 13 design labs and helps undergrads and PhDs with research. And his program helps students design circuitry and repair electronics, teaches advanced surface mount techniques, and energy power conversions. And the significant work produced by Roy Richard. He's an alumni from Georgia Tech's College of Engineering in 1935. He entered Georgia Tech's Engineering Hall of Fame in 1994. He is the founder and CEO of the Southwire Company during life. Facts about the Southwire Company. They are the leading electrical wire, cable, and cord manufacturing company nationwide, the nation's sixth most innovative user of technology.
Interns and co-op opportunities. I mean, for some interns, you can go off during the summer, and for co-ops, you can work during your studies. And either way, there's so much to gain from them. A few examples are just internships or doing co-ops with Intel, Microsoft, the Georgia Tech Research Institute, the TriQuint Semiconductor. Each of these will provide you a bit of an insight on the job that a computer engineer would hold. So you get sort of a feel of the things that you like, things that you don't like, and the salary projections for like starting computer engineering students fresh out of school. The median starting salary for Georgia Tech students is around $65,000. The highest starting salary may be $90,000. So that's the starting projections. Working and hiring in the field post graduation. There are definitely a lot more computer software engineers that are being hired. They design, develop, and test software. They make and install software updates. The software engineers will be able to go in and see its effects, see what can be improved. If we change this here, then this will run a bit better, or this will look a bit better. For computer hardware engineers, most of them will research, develop, and design computer equipment, old, outdated semiconductors, or very old technology. The majority of hardware engineers you will find 95% of them working in the metropolitan areas because I guess it's very high speed. So of course when they're there, they have a lot more people to look over with their hardware engineers when they have the supercomputers that will run entire cities. Yeah, They will need hardware engineers in major cities to make sure that the city stays up to date and connected the way it needs to be in order for people to be able to work day to day in their jobs. If they work in huge companies, they need those. So that concludes our computer engineering presentation, and I hope you enjoyed it. Thank you so much, and goodbye.
Computer engineering can be seen as important for different reasons to different people. For Kyle and Gabriel, it's the many possibilities in nanotechnology. For Oscar, it's to be able to design a better, faster, more efficient way of computing information. For Arnav sees it as a tool to help improve safety and security. Demetra sees it as a tool to better connect the world and hopefully bring more understanding with that connection. I see it as a way to push past our current limitations as a society by making use of our robotics capabilities.